Strength of London dispersion forces. Um, when you talk about how strong a London dispersion force is, there's really only one thing that you have to remember, and that is how big is the atom. And so the bigger atoms or bigger molecules will have stronger London dispersion forces. Now, with bigger atoms, it's because they have more electrons, and so they're more highly polarizable. And we'll talk, polarizables means they create poles, like the negative and the positive. So when you look at a periodic table, something like chlorine is going to have some London dispersion forces, but it's not going to be as strong as bromine, and it's definitely not going to be as strong as iodine. And so the halogens are really kind of the best way in to think about the strength of dispersion forces, because you got the guys at the top, the fluorine and the chlorine, they're gases at room temperature. Fluorine is actually very active, and we don't see that a whole lot outside of compounds. But chlorine, it's a it's a nice diatomic molecule, Cl2, and it bonds to itself with a covalent bond, and then it's a molecule that we encounter. It's a yellowish gas, but it's a gas at room temperature. Okay, because the only thing that is the only intermolecular force it's going to have, since it has that perfect nonpolar covalent bond, is London dispersion forces. And, they're just not very strong because chlorine doesn't have that many electrons. You move down and you're dealing with bromine. Okay, now bromine, in addition to mercury, is one of the only element that is liquid at room temperature. It's like it honestly looks like urine. But in its elemental state, it is a liquid. And the reason why is that, bromine, again, forms, it's Br2. It's got that nice molecule that it forms. And then that molecule, because it's a little bit larger, because it has, the extra electrons that chlorine doesn't have, it is a liquid at room temperature. And then you go down, iodine. Don't think that iodine's a liquid at room temperature. What you're thinking about as iodine is actually iodine dissolved in water and a little bit of alcohol. It's called a tincture of iodine. So iodine is actually a solid at room temperature. And so, when you think about it, fluorine has 9 total electrons. Chlorine has 17, and I'm sorry about the sun. It's kind of looking a little weird, but we'll get through it. Bromine has 35. Iodine has 53. And so the more electrons that are in the molecule in this case, because those are all diatomic molecules, the more susceptible it is to being polarizable and the stronger intermolecular forces that you experience. And so if something is a liquid at room temperature, you can say that it has stronger intermolecular forces than if something is a gas at room temperature. And it doesn't matter if the gas is polar and the liquid is nonpolar and only has London dispersion forces. If it is a liquid at room temperature or a solid at room temperature, that's going to have stronger intermolecular forces than if it is a gas at room temperature. That's just pure science right there. Doesn't matter what's holding it together. what type of forces. It matters the strength of the forces, and the strength of those forces come from a wide variety of factors. The biggest factor, though, is how big is your atom or molecule.